In this video we're going to continue with differentiation and we're going to learn how to prepare to differentiate. We looked at this briefly in the last tutorial video, but this will look at it in more depth. So we know how to differentiate by now, so we'll just crack on with some examples here. So the first one, we are going to look at differentiating more than one term, because all the examples that we've done so far, we've just been differentiating single terms on their own. So a function f is defined for x in the real numbers by f of x equals 3x cubed minus 2x squared plus 5x, and we want to find f dashed of x, the derivative. Now, you'll notice I've rewritten my 5x here as 5x to the power 1, and you'll hopefully see why in a second. So if we start by differentiating the first term, 3x cubed, remember 3 multiplied by 3 gives me 9, and taking 1 from my power, I'll get x squared. So f dashed of x is 9x squared. The second term here, I've got negative 2x squared, so multiplying my 2 by my negative 2 gives me negative 4x to the power 1. Need to take 1 off my power. And finally here, 1 multiplied by 5 gives me my 5, and taking 1 from the power gives me x to the power 0. Now, x to the power 0, remember, is always 1. So actually I've got 5 multiplied by 1 here, which just leaves me with 5 at the end. So my derivative here is 9x squared minus 4x plus 5. And that is my final answer. So before I change the slide, it would be a good time to pause the video and take this down in your notes. Welcome back, and we'll look at a second example here. So find dy by dx when y is equal to x minus 3, x plus 2. Now this is the first time in these videos that we've seen dy by dx, and it's just another way to write the derivative. Now obviously up here, f dashed of x, that was a function in terms of x, and then we were differentiating that function in terms of x. Here we've got y equals, and this basically means differentiate y with respect to x. So it means the same as f dashed of x basically. It's just this one was a function in terms of x, and this one is y equals, and that's in terms of x. So the solution then, we start with y equals x minus 3, x plus 2. Now we want to eliminate these brackets before we differentiate, so we need to expand these. So we should always be making sure that we're differentiating things in simplest form. So the way we learned how to expand brackets was using the grid method. So you can see here I've set up my grid, and expanding will get me my x squared, positive 2x, negative 3x and negative 6. Now if I collect like terms and simplify here, I get y equals x squared minus x minus 6. Now so far I haven't even differentiated yet. I've just expanded those brackets, and now I'm ready to differentiate. I have this, I can't do anything else with this, so I'm ready to differentiate this now. Differentiating the first term here, which is x squared, I get 2x, so dy by dx is equal to 2x. Looking at my second term, negative x, that will give me negative 1. And finally this negative 6 here, so remember we discovered a few lessons ago that constants, so numbers on their own, they seem to disappear, so let's have a further look at why that happens. So actually that negative 6 is equal to negative 6x to the power 0. So remember, x to the 0 is equal to 1. Now differentiating that, I'm going to get 0 multiplied by negative 6x to the negative 1. But remember, 0 multiplied by anything gives you 0. So that's why it appears that constants disappear when you differentiate, but actually because they are being multiplied by the power of their algebraic term, which is 0, That's why it disappears. So dy by dx, the derivative is equal to 2x minus 1, which is our final answer. So just now would be a good time to pause the video and take this down in your notes before the screen goes blank.